Alright, in this video what I want to do is show you how you can actually fudge in a coordinate system if you don't have coordinates for your scans, how you can inherit something that you're thinking might actually work, just to get it off of the assumed coordinate system that Scene inherits. So I created already a project. You see I called it fudge coordinates. Let me import at least 3 scans. I can minimize this. We'll save this. Okay, typically what I like to do is when I'm working with these, I load all scans. I do have a nice computer with a lot of memory, so it shouldn't have a problem loading just the 3 scans. Otherwise, when you have hundreds of scans, obviously you would skip this step. But I like doing that because it saves me a little bit of time later visualizing. Now let's do a very quick registration, and I will do a top-down registration. These are all my defaults are correct. I'll hit OK. Alright, we have some results. Not super accurate, but we can still refine them, and this is where I just do a quick update and change it to cloud now that they're close to each other, so see how that refines the placement. Alright, so we have better results over here. I happen to be in metric, so let me switch this to feet. And I like US survey feet because that way I know I'm not going to be introducing any conversion issues. When I'm switching display units, I always typically switch the import and export units too, just so that we're all on the same page and there's no issues. Alright, let's look at it. This happens to be a very simple roof of a building, but it looks like it stitched it together properly. I do seem to have the elevation worked out because I don't seem to have anything below, nothing above. So as far as data, I'm happy with it. Now say we need to inherit, and this is something that I get asked a lot, an elevation, and there's a wall over here. So let's say that we know a mark that we have on the wall over here, that we know the elevation is, I don't know, 100 feet. So if you look at our coordinates right now, it says 3x -5 over here and -243 for elevation. And we want to make a certain change to this coordinate system just so that we have the right heights. What we can do, this is done fairly easily, we can view one of these scans in the planar view, because in planar view we can look at this wall and say if we had a mark. Now we don't have a mark, but frequently I get asked, so what do I do if I don't have a mark? You can kind of pick one of these. This is like a little grout, and I can say, you know what, this is a point that I want to mark, and I'll mark it over here, and I'll just leave it be, hit OK, and then I'll pick another point on the same wall. Doesn't have to be the same wall, but I'm just proving a point that anything that makes sense actually goes. So I can just go ahead and, I don't know, we'll pick really just a random point on this wall again, hit OK. Now when we open up the scan manager and look in the scan, we actually have coordinates for a point here, x coordinate, y and z, and same deal, same thing happens over here. We have coordinates for x, y and z. Now these are the wrong coordinates because we actually want the elevations to be correct. So how do we fix this problem? Well, first step that you want to do is you want to lock your scan manager so that the relationship between the scans that we already have registered stays the same. What I recommend doing is you create a whole new cluster and call it, I don't know, georeferenced. Let's do that, georeferenced. Now I will grab this cluster and move it in here. That way I have a georeferenced cluster that has my local cluster in it, of course, already. Now you can do this two ways, but the easiest way is just going into new and creating a point. What we're actually creating right now is we need to create a folder that's called references, because that's what the software will look for when it's going to try to match points inside the references to the points that are inside the actual scan. So I'll call this references, enter. Now inside references I can create my new point, and this will be the point that will drive my elevation. So I'm a surveyor, so I will typically put in a 5,000 for local coordinate, 7,000 for my easting. Actually, remember this, scene always works with easting, northing elevation, so I like to do my easting as 7,000, northing is my 5,000, and my elevation 100, because somebody told me that, and I'll call this point number 1, somebody told me that we want to have this point over here at elevation 100. You can call it anything, of course, at that point, but let's say this is going to be 100. So now I have one point already that I know I can reference with this, and the software will figure it out. We haven't made that step yet, but now I need the second point for scene to be able to correlate the rotation also and get the right distance and essentially inherit a scale and a rotation. So how do we do that? The easiest way, again, and we're kind of fudging this because if you were a surveyor and you were actually shooting points in with a total station or a theodolite or a robotic instrument or even GPS, you would have the coordinates for this. But if you really are just, as I said, pretending that you know what you're doing and you're just trying to get it into a local coordinate system, this is how I do it. I picked the measure between objects tool, and we go from here to here. What the software does is it gives me a breakdown of what the distance between the horizontal distance and the vertical distance is from point 1 to point 2, and me leaving these values open, what I will create now, I will make a whole new point. I will call it point number 2, and because I want this distance, for example this wall, to go perfectly straight north, what I will do, remember I have my easting, which means that's my x location or x coordinate. I will leave it go straight, so this will be my coordinate for east will be unchanged, but my coordinate for the northing, which is the y value, I will adjust by the horizontal value. So I will copy this out of here, type it in here. So we're going 29 feet, 0.517 north from the location of point number 1. And then the elevation, because we do not know what it is, it's actually a little higher, and we know the vertical, we're about almost 4 feet higher. So we will input 10. Remember, we have point number 1 at elevation 100, so we have to add this value to here, so 3.9113. Hit OK. So the measurement served its purpose right now, but just to prove a point, as we're rotating around here, flying around here, we have the measurement, of course, in place, but you can still see that the coordinates are way off. Now, in order to inherit this made-up coordinate system, what you want to do is, I typically just close the views that I don't use, but here we go. We have 2 points that are our reference points, and we now want to register our georeferenced cluster, which will move this local cluster onto whatever it finds that correlates to the points that we just added. So these coordinates will be inherited by the cluster that has those points identified in one or any of these actual scans. So you will see that this point will be renamed 1, this point will eventually inherit the name 2 based on these two guys here. Let's do that. So right-click georeferenced, operations, registration, place clusters, or place scans in this case. I usually don't use the points for validation, but I will do a target-based registration and just hit OK. When this comes up, you will notice a little C next to each one of these 2 points, and me seeing these values and results shows me, okay, it must have kind of already worked. Let me verify that it actually did. You'll see that scene recognized them and renamed point 1 and point 2 to number 1 and number 2, which means if we now visualize the new scans in the cluster, you will notice when I pan down to my actual project, all my points are now relative to my easting 7,000, northing 5,000, and my elevation 115. So if we fly in really close to the point that we picked on that wall, which we called 1, we should be at elevation pretty much 100, and I don't know where I am, but I'm roughly in that height, and you can see that it's about the coordinates that we told it to be. If you want to verify where it is, you can always go ahead and tell it to locate the point, and it kind of gets you there. And then if you want to go here, and kind of takes you to the second point, and there you go. So now your coordinates are set, and your job has been just moved to a new coordinate system. To save everything, of course, I usually just hit save. At that point, it will stay at this state of the actual project. And I put in a comment saying georeferenced. And now we can proceed with the export if we're going to be doing anything after that. So obviously if you're applying colors, you can apply colors, but I'm really just, and I can really just export this into a recap file. So let me close this. I'm finished with my project. All I do is open up recap, and I'll make a new project. I typically like to put my projects into the same folder where my actual project, the scene project is. So I'll go here and I'll call it recap. I will select this project. We will go and call this fudge coordinates. Enter. Import my project from scene, open, and of course this is where you have to wait for the indexing to get done. Okay, now that everything's indexed, when we launch the project, you'll notice, again recap always defaults to meters. But you will notice that we are not just on arbitrary coordinates, but we happen to have a height of about 29 meters, which essentially is about 100 feet. So this project now inherited the same coordinate system that we let Scene, create by registering the cluster that we had. And all you have to do is typically just hit save over here and close out of here, and unless you want to do some work in recap, of course. But next step is bringing it into AutoCAD or Navisworks or recap, and I wouldn't mess with any of the units over here because the most of the work will be done in AutoCAD or the other program beyond recap, and that's where I would specify my units. So we close this, and I will just open, let's do Civil 3D. And I happen to have Point Sense installed, so I can go into Point Sense and actually insert my point cloud, but it really doesn't matter how you do it. This is really just the insert command. And we'll go into the recap folder, open the recap project. Length of units that the scan point cloud is in is meters, but I want to see US survey feet. Hit OK. And now, while I'm actually here, let me turn on my coordinates. There we go. Which means you can see that I'm actually hovering over top of the 7,000, 5,000 coordinates. Elevation obviously is not being shown. Hold on. Let me do my orbit. Orbit auto target. We want to make it 0. Okay. This way we'll be pivoting around where my actual cursor is. But if I create a point right now, just do a manual pick. I'll pick it somewhere here where that ground is, for example. We'll call this, I don't know, let's call it wall. You see the elevation's pretty darn close to 99.93, which is where we selected it at 100. So I know that point's now created on the right coordinate system. So there you go. This is pretty easy to bring it into AutoCAD or Civil 3D. If you don't mess with too many settings in Scene or Recap, it's easy to just mess with these settings afterwards in AutoCAD.